Hello everybody, welcome to tutorial on electrical circuit analysis. Today we are going to see mesh and nodal analysis problem in AC supply. So in previous video we seen mesh and nodal analysis in DC. Now we are going to see how to solve the problem in AC. So before going into the problem, first of all we have to know how to convert from polar to rectangular and rectangular polar in a calculator. So for this I used 99ms, FX 99ms calculator. So please take your calculator. If you want to convert your polar form to rectangle format, you have to use the following procedure. So you can, one example is given here. So convert from 5 angle 35 to rectangle format. So use your calculator. First press the shift button. It is mentioned here, shift button. Then press a bracket open button. You first press the shift button and there is a button in the last before the row of the calculator. You have a button called REC. You press that button. Once you press the button, automatically it will show REC bracket open. Okay, now type 5, 35. Now close and press equal to. So now you will get the imaginary part of the rectangle, that is 4.09. Now you get the complex part, that is imaginary part. Press RCL and tan. So you will get a 2.86. I will repeat once again. Now to convert from polar to rectangular. So that is the example given 5, 35. So press shift button, then press a rectangle button, then press 5, 35, then close bracket. Press equal to, you will get 4.09 real part, then press RCL and tan, you will get a imaginary part 2.86. So if you want to recollect the answers, you can press RCL cos, you will get the real part, RCL tan, you will get the imaginary part. So this way you can convert polar to rectangular. Similarly, from polar to rectangle format, same way, the example is given 3 plus J4. Press shift and press a button pole 3, 4 and then bracket close. So then press equal to, you will get the real part R 5. You will get the R as a 5. Okay. Then press RCL tan, you will get the angular format. So we will get the magnitude and the angle by using this above format. So if I want to recollect the data, press RCL cos, you will get the magnitude part, that is R. Then press RCL tan, you will get the angular part. So this way we can convert from polar to rectangular and rectangle polar. So for more details, you can refer the following link also. It's given in this slide. So some more examples, but before going to do any rectangular to polar or polar to rectangle, some rules should be followed. So the rules are, please follow only this rule, then only your answer will be get corrected. So if the values will be in the rectangular, so please do only addition subtraction is allowed. So if you are doing multiplication and division, it is very complicated. Still we can able to do the multiplication and division in rectangular format, but it is somewhat complicated, because if in case of division you will be getting in form of lengthy equation. Similarly, in case of division you have to take a complex conjugate, so it will be somewhat lengthier format. So rather you can do only addition and subtraction in rectangle. So in polar format you can do the division and multiplication. So some examples is given here. You can see that Z1 and Z2 are the two values. If I want to divide, say R1 and R2 are divided, the angular part we have to subtract in division. Similarly in multiplication, Z1 and Z2, if I want to multiply, means R1 and R2 will be multiplied, the angular part will be added. So in multiplication the angular part will be addition, in division the angular part will be subtracted, but the division will be as it is and multiplication will be as it is. So it is recommended, so do the addition and subtraction in rectangle format and do the multiplication and division in polar format. Please practice the above method to convert the different types of polar to rectangular and rectangular to polar. So then only the problems in AC you can easily able to solve. Okay, we'll go to the first problem. Using mesh analysis for the given figure, find the current I2 and drop across 1 ohm resistor. I2 is the current is nothing from the loop 2 and the drop across 1 ohm resistance is loop 1. Okay, we'll go to this problem. Since this is an AC problem, solving the problem in KVL is very difficult. So it is suggested that you can easily solve this problem in a inspection method. We will see the circuit consists of 2 loops. So based on the direction of the battery, the arrow marks are drawn. So if the arrow mark is given in the question, we have to go as per the direction of the battery. So the battery direction, based on the battery direction, the current direction is given. Okay. So we'll have 2 loops. So we have 2 cross 2 matrix. So the first loop consists of 1 ohm, 4 ohm and 2 ohm and 8 ohm. So sum of the element in the first loop. So we have to sum the real values, that is real values is nothing but only the resistive component, and then imaginary components is nothing but the inductor and the capacitive components. So one thing you have to note, in inductor the values mostly given in positive values J 2 ohms, J, but in capacitor it will be mentioned as minus J. Why? Because the capacitive reactance SC is mentioned as 1 by J 2 pi FC. So if the J goes to the numerator, so it will become minus J. So in this way the capacitive reactance I have to put in a minus J. So here as per this problem it is 1 ohm and the inductor is J 2 ohm and capacitor is minus J 8 ohm and resistance is 4 ohm. So we are summing up all these elements. There is 1 plus 4 plus J2 minus J8. So we got 5 minus J6. Next is common element between loop 1 and 2. So here the common element 1 and loop 2 is 4 minus J8. Since the direction of the current is in the same way, so it is a positive direction. So it is not opposite current traveling in the common element. So the same current is traveling in both the both current are traveling in the same common branch. So that's why we put it in plus instead of minus. So it is 4 minus J. That is Z1 2. Next one is Z21. So Z21 is also this is a common element between 2 and 1. Once again 4 minus J8. Next is the sum of the element in the loop 2. So it is minus J8, 4 plus J6. So it will be 4 minus J2. So this way this matrix is constructed. Then this is called Z. Then I1, I2, then equal to voltage. So voltage, if you see the first loop, we have 2 batteries are connected in series. So 8 angle 20 and 10 angle 0. So this will be just like a connected in series fashion. So we can put 8 angle 20 plus 10 angle 0. The next, if you see, we have only one battery in the second loop. So we have 10 angle 0. Why it is positive means because the current is leaving from the battery. So that's why you put positive. But suppose current is away from the battery means it is negative. So the current is leaving from the battery. So it is 10 angle 0 is positive values. So once the matrix is constructed, then we can go for the calculations as we discussed in the previous video. So we got this matrix. So first simplify all the equations. So I simplify this equation. So please check the calculations also using a calculator. Now I got this Z matrix, I matrix and a V matrix. So I converted into rectangle to polar to rectangle first, then I got it in the rectangular format. So first I find out the delta. So delta is the Z matrix. So find out the determinant of this matrix. So 5 minus J6, 4 minus J8, 4 minus J8, 4 minus J2. So find out the determinants. So I given the full detailed calculations in this slide. So please check it out. Once all the values are okay, then I got the value in the form of rectangular format. Here one thing you have to note. So I done multiplication addition, subtraction, everything in the rectangular format only. So multiplication, as I already mentioned, multiplication we can do, but it will be somewhat lengthier what is mentioned here. Okay, so whichever possible easiest way you can proceed that way. So here I done multiplication in the rectangular format and I expand the equation, then I finally got the reduced simplified expression minus 40 plus j30. Then I converted it into polar format. So I got this radius and the angle. So this is the delta. The same way, so delta 1 is found out. So delta 1, as I discussed earlier, so the first row is replaced with the voltage matrix. Okay, first row is replaced with the voltage. So voltage matrix is a nothing but the 20 then 8 angle 20, then plus 10 angle 0 is addition, then other one is 10 angle 0. So this will be the voltage matrix that I put it in the first row, keeping the Z matrix second row is as it is. Once again do the simplification, find out the determinant, then I got 66.27 and 57.55. Now we know how to calculate the I1. I1 is nothing but del 1 by del. So substitute this one, del 1 value del, and then I got 1.32 angle minus 85.45 amps. So please check the calculations, then understand the problem. The procedure is what I discussed is okay, but if any minus, plus and small deviations in the calculations, please correct yourself, because sometimes taking 2 digit, taking 3 digit, taking single digit after the decimal, the calculation might be go deviated values. So please put take always 2 digit after the decimal, so that it will be easy to get your exact values. Next L2. So once again, second column is replaced with the voltage matrix. To find out the determinant. Now after defining the determinant, I got 80.95 angle 238.7. So we will always get the values in the rectangle format only, but you have to convert into polar format. Why we have to convert to polar format? That one, then only we know the magnitude of the current or voltage. So we got the polar format values after doing the rectangle to polar. Then once again find out the I2. Then I2 will be getting 1.61 angle 95.7. So this way we can find out I1 and I2. So I2's current is, as in question they ask I2 current, that is 1.619 95.74 amps. We'll go to the next problem. Next is a nodal analysis problem. So as I already mentioned in the previous videos, how to find out the node and how to find out the equation, everything I mentioned. So I apply the KCL and wrote the equation. But as I mentioned in the previous slide, so instead of finding out the KVL or KCL equation, it is better to use the inspection method to find out the final answer. So I use the inspection method to determine the V1 and V2. So here the M is one node and N is another node. So in M we have 3 elements joining, and N we have 3 elements. So we will see first one, it is 1 by Z11, that is 1 by 5 plus 1 by 2j plus 1 by 4. This is a Z11, 1 by Z11. Next one is minus 1 by Z12. So the common element between M and N is minus 1 by 4. Similarly 1 by Z21, this is once again minus 1 by 4. Next one is Z22, 1 by Z22 is 1 by 4, 1 by 2 and 1 by minus J24 equal to, then V1, V2 is a matrix, voltage matrix, then current in the first node and current in the second node. The first node current is 50 V by Z, that is 50 angle 0 by 5. Then similarly current in the second node is 50 angle 90 by 2. So this way we can construct a matrix. Then the calculation will be as it is what we see in the previous slides. So find out the determinant. So I got 0.61 is the determinant, then minus 14.26. Then del 1 is, so in same way replace the first column with the current matrix, do the calculation, find out the determinants. So we will be getting in the rectangular format, convert into polar. Then we will be getting the answer V1 equal to del 1 by delta, so it is 15.36 angle 51.11 volts. Next one, similarly find out the delta 2, replace the second column with the current matrix, find out the delta 2, then I am getting 18.75 angle 36.87. So finally V2 is 30.74. So this is another problem, third problem. This problem, instead of finding out the current, we have to find out the unknown voltage V2. This is the unknown voltage V2. So this problem is a very important problem. In most of the university question paper, you can find out this type of problems. So how we'll solve this problem, we'll see. First we'll see the question. For the circuit shown in figure, determine the value of V2 such that the current in the 3 plus J4 ohms impedance is 0. That is, the center branch is 0. That is, I2 is 0. It is mentioned indirectly. That is, 3 plus J4 is 0. That means the current is 0. I2 is 0. So based on this things, we have to construct the matrix. So the matrix and all we discussed already earlier. So this is a 3 cross 3 matrix because we have 3 loops. So construct the matrix accordingly. So first loop is 4 plus J3. Then common between first and second loop is minus J3. Then common between first and third loop is 0. Similarly, the second row, common between second and first is minus J3. Then the sum of the element in the second loop is 3 plus J2. That is 3 plus J4 plus J3 minus J5. So if you sum all this, we will be getting 3 plus J2. Next is common between 2 and 3. I put minus J5 because the direction of the current in minus J5 is same direction, this way. That's why I didn't change the sign of this capacitor. It is simply J5 only. Next one is third row. It is 3-1 R31. So there is Z31. It is a common between 3 and 1. So no connection between 3 and 1. So it is 0. Once again, that is the next common between 2 and 3 minus J5. Then sum of the element in the third 5 minus J5. So this is the Z matrix. Then current matrix. Then voltage matrix. Voltage matrix, first loop is 20 angle 0. Second loop we don't have any voltage. Third loop they given V2. So as it is, we put the voltage matrix and construct the entire matrix. Now we'll find out what is the V2. So first find out the determinant as it is. So the calculations are given in detailed fashion. You can check the calculations. For detailed calculations, how to find out, you can refer the previous videos also, or I find out the determinants. So find out the determinant. So finally I got 260 plus J 175. Next, I am going directly to delta because I want V2. So I am finding out the delta 2 directly because in question they are not mentioning to find out the I1, I2, I3. They simply ask to find out V2. So I am going to delta 2 directly. So in delta 2 only we can, why we are finding out delta 2? Because in delta 2 only we can substitute that I2 because I2 equal to delta 2 by delta. So I2 is 0 is mentioned in the question. So I use the delta 2 now. So replacing the second column with the voltage matrix. So find out the equation and find out the determinant. So finally I got this equation J20 V2 minus 15 V2 minus J300 plus 300. So this equation I got it. Now I go to the I2 equal to delta 2 by delta. Substitute the delta 2 and the delta. Then I2 is 0. It is mentioned in the question. I2 is equal to 0. So simplify the equation, then finally I got V2 as minus 16.9 angle minus 8.12. This is the V2 voltage. So all the thing is we have to observe the question carefully and think what we have to do based on the questions. So it is mentioned I2 is 0 since the current in the 3 plus J ohms impedance is 0. So thank you for the listening the video. So next problem we will see the AC analysis.